Hi, this is Robert Bragalia here at XiComputer Corp. Today we're looking at our XI Supercomputer Cluster, and let's take a look at how we built it.
Here for Rack 1, as highlighted by our laser pointer, there are 4 login head nodes connected to 3 types of bare metal cluster nodes, which are computational nodes, high memory nodes, and GPU nodes. The connection between all nodes is implemented via 2 different networks. 1 gigabit Ethernet network controlling the Intelligent Platform Management Interface, or IPMI for short, for monitoring, and a 10 gigabit network that is used for data transfer between each cluster and each node. The first subcluster is a computational one. We have 8 3U rack systems, each with 4 nodes, dual Xeon, scalable 4214, 12 cores for a total of 760 CPU cores on 1,536 threads. All of these computational nodes are also connected via a 40-port NVIDIA Mellanox InfiniBand 200 gigabit switch using QFSP 100 gigabit split cables. In the second rack, we have 8 high memory nodes for a total of 10. Each of these 1U units contains 2 nodes, each with 2 terabyte XiSCC RAM and 2 Xeon 4214 CPU, all connected via the 10 gigabit network interface. The second part of Rack 2 is composed of 12 GPU nodes, each containing 2x NVIDIA Tesla V100S 32 gigabyte graphic processing units, for a total of 32 GPU. This is an impressive amount of computational power: 122,880 CUDA cores and 16,360 tensor cores. All of those are supported by the same 12-core Xeon CPU, 1 per Tesla GPU. When we talk about a supercomputer, we also talk about a lot of power. And here is where the power is coming from. We have 4 3-phase special plugs connected to 4 17.5 kilovolt ampere power distribution units, or PDU, 2 per rack, distributing the power evenly throughout the units. Our cable management system efficiently and cleanly routes the power cords, the 1 gigabit and 10 gigabit network cables, and on this right side rack, you can see the Mellanox QFSP cables connecting all the computational nodes, plugging in with gentle curves as these do not bend. The XI Supercomputer Cluster, or XiSCC, is designed, optimized, and custom-built on dual-socket rack enterprise server platforms, both Intel Xeon and AMD EPYC-based, with optional NVIDIA Ampere GPU and fiber connectivity to maximize CPU and GPU density per 1 unit rack. XiSCC can install the latest Linux flavors: Oracle, Red Hat, SUSE, Ubuntu, Fedora, Scientific, Mint, and Debian. It can be custom configured with OpenStack Cluster Management, Horizon, that's OpenStack's dashboard web-based interface, and Blazor, which is the resource reservation service for OpenStack, Linux plugins, among other data center management software. These software packages are the foundation of most standard supercomputer platforms deployed as infrastructure as a service for both public and private clouds, allowing users to access virtual CPU, GPU servers, and other computational resources on a shared basis. Our expert engineers will optimize the required hardware and software virtualization, maximizing your ROI to better suit your needs for both Linux and Windows-based applications at the best prices. At XI, engineers combine decades of experience, confidence, flexibility, and the expertise to handle all phases of a rack data center integration project. From requirements gathering to final delivery of a turnkey solution and every phase in between, you can rely on our XI Rack Integration Solutions as the main resource for your project's success. With an extensive line of servers, storage, switches, and rack products, we can provide a wide range of optimized solutions that translates to great customer experience and satisfaction quality, price, performance, as well as energy efficiency.
This concludes our brief presentation of our XI supercomputer clusters. And if you think this is a $1 million deal, well, we were able to build this for a lot less. So we will be happy to also build yours and help on the configuration and the feasibility study and the bidding process for your next supercomputer cluster. Thank you very much for watching.